Welcome to an introduction to the OSI Layered Architecture, a fundamental concept in computer networking that standardizes how different systems communicate. The Open System Interconnections model is a conceptual framework that divides the communication process between systems into seven different layers. Each layer has a specific role, allowing devices from different manufacturers or networks to communicate seamlessly. When a data is sent from one device to another, it is encapsulated into PDUs at each layer. As the data moves down through the OS layers on the sending device, each layer adds its headers or trailer. The data is then transmitted across the network. At the receiving end, the process is reversed. Each layer removes its corresponding header or trailer to extract the data. So the PDU or protocol data unit is the combination of data, header and trailer. The Open Systems Interconnection Reference Model is a conceptual framework developed by the International Organization for Standardization to standardize and simplify network communication. It divides the complex process of network communication into seven distinct layers, each with its functions and responsibilities. From bottom to top, the seven layers of the OSI model are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The first layer is the physical layer. The physical layer is also known as layer 1, is the first layer of the OSI model. It is responsible for actual transmission of raw data over the physical medium. This layer deals with physical aspects of networking, including the hardware technology that transmit bit across the network. Some of the key functionality of the physical layers are transmission of raw bits. The physical layer converts data into electrical, optical, or radio signals that can travel over the network physical medium. This means turning binary data, zeros and ones, into signals that can be transmitted over cables or through the air. It defines the physical characteristics used for communication, such as cables, fiber optics, or wireless channels. The physical layer is responsible for encoding the data into a format suitable for transmission. It handles the synchronization of data transmission between devices, ensuring data is sent and received at the correct time. The physical layer defines the network's physical topology, including how devices are physically connected and how data flows through the network. This can include star, ring, bus, or mesh topologies. Examples of physical layer technology: Ethernet cables. These are the familiar cables that connect computers in network using electrical signals. Fiber optic cables use light to send data over long distance very quickly. And Wi-Fi, this technology uses radio waves to connect device without wires. The physical layer is crucial because it enables data transmission. It is responsible for sending data across the network. It tells us what hardware is needed for the network to work. The type of physical medium can impact how fast and reliable the network is. The data link layer is responsible for making sure that data is transferred correctly over the physical connection. It acts like a traffic controller for data within a network. It takes the data from the physical layer and organizes into units called frames. Each frame includes not just the data but also information about the sender and receiver. Error detection and correction. In this case, it checks for errors that might have occurred during data transmission and can correct these errors to ensure data integrity. It manages how devices on the same network share the communication medium, preventing collision when the two devices try to send the data at the same time. It uses MAC addresses to ensure data is delivered to the correct device on the network. Examples of data link layer technology, network switches. These devices operate at the data link layer, managing data traffic within a network. Network interface cards. These cards in your computer handle the data link layer function, including addressing and framing data. The data link layer is important because it ensures reliable data transfer. It makes sure data is transmitted correctly between devices on the same network. It controls how devices share the network, avoiding data collision. It detects and fixes errors that might happen during data transmission. The network layer is responsible for moving data from one network to another. It acts as a navigator, directing data to its destination even if it has traveled to across multiple networks. What does the network layer do? It detects the best path to travel from source to destination. This is especially important when data needs to pass through several networks. It uses IP addresses to identify devices on the network, unlike MAC addresses that are used within the local area network. IP addresses are used to route data across different networks. It breaks down data into smaller packets and ensures these packets are sent to the right destination even if they take different routes. It keeps track of data as it travels and helps ensure it reaches the correct destination. If the packet gets lost or needs to be retransmitted, the network layer helps manage this. Routers, these devices operate at the network's layer and are responsible for detecting data packets between networks and across the internet. IP addresses are used to uniquely identify devices on the network and help route data packets to their destinations. The network layer is crucial because it ensures the data finds the best path across various networks to reach its destination. It uses IP addresses to manage data routing across the internet and large networks. It enables communication between different networks, allowing them to communicate and share data. The transport layer is responsible for making sure that data is delivered reliably in the correct order and without errors. It is likely a delivery service that ensures the packages arrive at the right place and in perfect condition. Transport layer breaks down large chunks of data into smaller units called segments so they can be sent over the network and then reassembles them at the destination. It makes sure that all data is received correctly and in the right order. If any segments are missing or corrupted, the transport layer handles retransmission. It manages the rate at which the data is sent to prevent one device from overwhelming another. This helps avoid congestion and ensure smooth communication. It checks the errors in the data and corrects them if necessary, ensuring that the information is accurate and intact. In protocols like TCP, the transport layer establishes and maintains a connection between two devices until the data transfer is complete. The two important protocols in the transport layers are TCP Transmission Control Protocol, UDP User Datagram Protocol. TCP provides a reliable, ordered, and error-checked delivery of data. It is used for applications like web browsing and email where accuracy is crucial. User Data Protocol is faster but less reliable than TCP. It is used for real-time applications like online gaming or video streaming, where speed is more important than perfect accuracy. The transport layer is important because it guarantees that data arrives without errors and in correct order. It controls the flow of data between devices to prevent overload and maintain efficiency. It supports different applications, whether accuracy in the case of TCP or speed using UDP is needed. The transport layer has a solution for different types of data transmission. The session layer is responsible for setting up, managing, and terminating the communication or session between two devices. Think of it as a meeting coordinator, ensuring smooth communication between systems. It sets up the communication link or session between two devices, allowing them to communicate effectively. The session layers ensures that the connection remains open and active while data is being exchanged. It can also synchronize data exchanges by using checkpoints. So if a disruption occurs, the communication can resume from the last checkpoint. Close sessions. Once the data exchange is complete, the session layer closes the session, freeing up resources. It can manage multiple sessions between devices, keeping each one separate and ensuring that the data from different sessions does not mix. The session layer is important because it ensures the communication link between devices stays open until the job is done. It can recover from network disturbance by resuming from where the session was last synchronized. It manages and coordinates multiple communication, ensuring they do not interfere with each other. The presentation layer is responsible for translating data between the application layer and the network layer. It acts as like a translator, ensuring that data is in the correct format for communication between devices. What does the presentation layer do? It converts data from one format to another format so that different devices and applications can understand it. Data encryption and decryption. To ensure security, the presentation layer can encrypt the data before it's sent and decrypt it when it's received. It can compress the data to reduce the size of the files being transmitted, speeding up the communication process and reducing the bandwidth usage. And finally, it ensures that data sent from one device is presented in a way that the receiving device can understand, converting data formats such as images, text, or video. The presentation layer is important because it makes sure that the data can be read and understood by different systems and applications. It encrypts data for security, ensuring safe transmission. It compresses data to reduce transmission time and optimize network performance. The application layer is where communication between software applications happens. It is the layer that users interact with, enabling programs like web browsers, email clients, and file transfer application to communicate with the network. It provides an interface for the users to interact with network services through applications like browsers, email clients, or messaging apps. The application layer handles requests and responses between the software application and the network, making sure data can be sent and received. It allows applications to access various network resources like file servers, printers, and databases. The application layers use specific protocols to perform tasks. For example, HTTP is used for browsing websites, SFTP for sending emails, and FTP for transferring files. The application layer is important because it is the layer users interact with, allowing them to access services like the web, email, and file sharing. It ensures that requests from applications are sent and received properly across the network. It supports many protocols and services, enabling everything from web browsing to database access. Thank you for watching.